Yeah. So we were in the VSV6. That was the prescription of the glasses. So now, as I was saying, for the prescription of the glasses, you need a retinoscopic cross, and how we are going to achieve the retinoscopic cross is by the help of the retinoscopy, and we'll make it. Now the first step after making this process, you have to assure whether is in the question there is any mention of the distance or the tonus allowance. Then we have to deduct for that tonus allowance and the distance as well. So if there is the examination is being done at 1 meter of the distance, the tonus allowance will be 1 diopter, and for the distance deduction will be 1 diopter, and for the tonus allowance for the atropine it will be 1 diopter. It will be 1 diopter. For home atropine it will be 0.5 diopters, and for the cyclopentolate this will be 0.75 diopters. Now we have achieved our retinoscopic cross, and we have deducted for the distance and the tonus allowance. What is the next step? First, calculate the finding. Deduction done. If only spherical error is there, error is equal on both the axes. But for the astigmatic prescription, we have to choose. There will be different numbers on both the axes. So we have to choose either one as the sphere. There is no protocol. Choose any one as the sphere and mark the other axis as x. Now calculate the cylinder as x minus s and choose the axis of the cylinder to 90 degrees of the x. Now to simplify these terms, let us take this example. Okay, let us take the first example. After my retinoscopic crossing and deduction and everything, I get this value plus 4 and plus 4. Both the axes have same number, same sign. It means this is a spherical error. This is nothing, just a simple hypermetropia. Okay. Now, but in the second image, you can see that both the numbers are different. It means there is astigmatism is there. This is astigmatism. Now, how we are going to prescribe the lens is choose any one as the sphere. So, for example, I am choosing -4 as my sphere. So, -4, because since it is a spherical number, it will be present all around, and cylinder will be present on the one axis. You know that. So, -4 will be here also, and -4 will be here also because it is sphere. Now, since I have chosen -4 as my sphere, so that means my this axis has the cylindrical number, that is -3. To get the cylinder power, I have to do x minus x. So I will do -3 minus -4. Okay, so I will be doing -3, that is x minus x. No, so it will be -3 minus -4. So it will become -4 minus 3 plus 4. So it will become -4 and plus 1. So this my prescription will be -4 ds, that is the spherical number, plus cylinder, and we know that cylinders exert their power 90 degrees to their axis. Okay, so the axis of the cylinder will be 90 degree of the axis. So it will be the cylinder power is here, -4 is the sphere, and cylinder is this axis. So the power exerted, this is the 180 degree, so the power exerted will be 90. So my prescription will be -4 sphere plus 1 cylinder at 90 degrees. Fine. So they have asked us in the question also retinoscopic cross of a patient under atropine from a distance of the second image. Okay. So from the second image we can do either one thing this or other thing if I am considering -3 as my sphere. So let us calculate from that also. Okay. So I am taking -3 as the sphere. So my -4, this axis has cylinder. So my this axis will become -4 minus -3. Is it fine? Okay. So my this retinoscopic cross will become -1 and -3. Fine. Is it fine? -1 and -3. So my answer will become minus sphere -3 spherical number -1 cylinder at 180 degrees, because I have to choose the axis 90 degrees of the cylinder. So the answer will be minus 3 sphere minus 1 cylinder. So let us see which of the option is in the question. So minus 2 sphere, okay, minus 2 is not my answer. So both these options are correct or wrong. Minus 4 sphere, both are in the option. Plus 1 cylinder at 90 degree. I have got this number. So my answer is this. Last option was minus 4 sphere minus 1 cylinder at 180 degree. This is not the answer I have got. I have two answers. What are those answers? Minus 4 sphere plus 1 cylinder and minus 3 sphere minus 1 cylinder. Okay, so you can take either of the number as sphere, but you have to deduct cylinder minus sphere for the cylindrical axis, and then you have to choose the axis 90 degree. Fine. Take one as sphere. For subtraction, you have to subtract cylinder minus sphere, and next is last step is the choosing the axis that will be 90 degrees to the axis of the cylinder. So this is how we are going to prescribe the plan. Next is the VSV7, that is the Titmus fly test. This basically a test for the stereopsis. You can be given this image in the question, and this is basically a test for the stereopsis. This is made up of two plates. The first one is the fly test, that is the fly test. This is done for the gross stereopsis, and the subject is asked to pick up one of the wings of the fly. We are asked to pick one of the wings of the fly for the gross stereopsis. While the second image contains the animal test, it has three rows. It has three rows of five animals each. Can you appreciate 3 rows of 5 animals? And the subject is asked which animal among all these stands out, which is the odd one out basically. That which animal stands out is the second plate, which is test for the stereopsis. Now I hope you know what is stereopsis. Stereopsis is nothing but this is how we achieve the binocular single vision. Okay, so there are 3 steps of the binocular single vision. One is the simultaneous perception. The first step of binocular single vision is the simultaneous perception of two dissimilar images. Can you appreciate? This is dissimilar images and we are simultaneously perceiving it. The second step is the fusion. The fusion, again, the fusion has similar images but with some differences. Similar images, but one of the images incomplete. Okay, see, in one image there is nothing the rabbit has holding, and one image this is the complete image. So we are fusing both the images. These are similar images. The last step is the stereopsis, that is the depth perception. That comes whenever there is angulation. Angulation. Similar images but with some depth changes. Okay, so you can be asked in which of these steps there is dissimilar images in the simultaneous perception, while the fusion and stereopsis contain similar images. These are the 3 steps of the binocular single vision. Now the question was, Titmus fly test is used in simple stereopsis, that is the depth